Invertible functions are 1, 1 and onto. In this module, you will learn how 1, 1 and onto functions are related to invertible functions. Recall that a function is a relation in which each input is related to exactly one output. Now let's understand what the inverse of a function is. Suppose we have a function f that maps from a set x to a set y. All elements in set x form the domain of the function, and all elements in set y, which are associated with the members of set x, form the range of the function. If we reverse this function, all elements of set y form the domain and all elements in set x form the range of the reverse function. Such a reverse function is called an inverse of the function f. It is denoted by f with -1 in superscript. It is not necessary that the inverse of every function is a function. Let's understand this with the help of an example. Look at this function g. Since no two elements in its domain have the same image in its codomain, g is a 1, 1 function. If we find its inverse, it is not a function, rather it is a relation. This is because every element in the domain of the inverse relation does not have an image in the codomain. If these two elements would not be there in the codomain of G, then the inverse of G would be a function. When we remove these two elements, every element in the codomain of G has some pre-image in its domain, so G also becomes an onto function. Now if we find the inverse of this 1, 1 and onto function, it is a function. Thus we can generalize that a function is invertible only if it is 1, 1 and onto. Conversely, we can say that a function that is 1, 1 and onto is invertible. In this module you have learned a function is invertible only if it is 1, 1 and onto. Conversely, a function that is 1, 1 and onto is invertible.